up there.
That's
So
just one of the criteria that has to
that's
be
fine.
met for quantum
One of the
locking to
one of the
occur.
criteria also is that they would have to move as if they are being quantum locked. And guess what? They kind of are. They kind of are.
Well,
In this, and
it needs
when you're
And
measuring that
kind of-
temperature, you're measuring the surface of whatever that fluid is. It could be colder the higher and the deeper you go. You know, like the top of the
But
turkey
we're assuming again
is going to
that
be
the
warmer than the
temperature-
inside of the turkey.
Again, we just got.
Well, I hear just the
assuming-
superfluid being talked about, Jace,
We're
right now. So
assuming-
you're jumping to the
We're
conclusion of
assuming-
quantum locking. So, like, can
No,
you
that's
address
what
just
you're
the
doing.
superfluid part? No, we won't go there first. First, do the conditions exist that you could have a superfluid above us?
No,
That would be the first
only
step.
the temperature variable exists. That's what I've been trying to tell you. Quantum locking, superconductivity, superfluidity.
Oh, now we do have the
has
temperature
more
variable.
variables.
Now we do
Well,
have
as
it.
I was
Okay,
saying
got
before,
it.
we're assuming that the temperatures even work, that they're in the range of a superconductor, right? I don't know that for sure. I could look it up in a few minutes, but at the moment, I don't know that that is actually true, and I'm leaning towards that it's not. But I'll look it up. But number two, that's not the only variable that has to be met for quantum locking to occur. There's much more to it. So just because you had the temperature right, even if you had the correct material,
Hold on, we haven't given a mechanism.
You can't just jump to the conclusion that quantum locking is going to occur because it's one variable. This one criterion of the many has been met.
Well, I mean, we don't know how space and time bends and if it bends uniform everywhere in the universe. So maybe there's something strange going on in the sky with space and time.
We're talking about superconductors and quantum locking.
Mm-hmm. Yeah, you don't think they use the principles, like the laws of the universe?
They use.
They have to, obviously. They use established laws.
They use the laws of quantum field theory, right? We're not talking about general relativity and space time and bending space time. We're talking about quantum field theory.
Okay, so is it possible that the space up there acts in that way, according to quantum field theory?
Anything's possible. Do you have evidence that it acts that way? Right? Anything's possible. It's on the person.
Yeah, it looks like it acts that way. We're watching.
It's on the person making the positive claim to actually provide the evidence. And for scientists watching it, looking at it, it's not evidence to come to this kind of conclusion. You got to have measurements. You got to show the mechanism. You got to show the variables are met. You got to do the scientific process before you start making the claims.
Anything is possible is a positive claim.
I have a question.
Not a positive
do you guys
claim.
think? I have a question, please. Do you think that they haven't got all that figured out there yet?
No.
Like, let's say at the Kármán line pass, you don't think they have figured out and measured the temperature, the movement of the fluid-like medium?
Well, I
you don't
would
think they figured that out?
The physicist at the university
Because
I go to, and
have satellites up there, right?
Yeah.
After all these years, they're like a million miles from the Earth. You don't think they got it figured out?
Dude, what is wrong with you, man? The physicists who work at the Ivy League university I attend, they're just now really figuring out superfluidity, superconductivity, and they're in the beginning processes of that. And this is Ivy League universities working with each other. But you're going to say that the government has a better understanding?
They have a vested interest. They have a vested interest. Dude, they had a space program. They would absolutely want to test the sky.
Yes, and you know who they recruit when they have vested interest? They recruit the top people in those fields who work usually at universities.
Occultists,
and usually
Freemasons,
the top
Nazis,
are at
propagandists.
Universities. So when I go to school and I see that and I talk to physicists and they're like, yeah, we're just really figuring out how this all works and what the applications can be.
Do you think that's the only resource that your university?
Yeah, he's the top of the totem pole, apparently.
It's not just that one. Right? You didn't listen to what I said. So when the government has a vested interest in things, because I've done contracts for the government, the National Institute of Health, I kind of have experience with how it works. Right? When they have a vested interest in something, they recruit scientists and engineers and whatnot to develop that. Now, where do those people usually come from? They come from universities typically. Sometimes they come from industry. The top ones are typically at Ivy League universities. So when the Ivy League university researchers say that they're just starting to understand this thing, I find it hard to take on face value that Space Force, a recently created government entity, has this huge secret people that are working for them that know all this stuff.
It's nothing. I just told you, 40s and 50s, the Space Force was even beginning way back then, bro. I don't believe in the Space Force. I'm using them as an example because they have the money to invest in this kind of stuff. And guess what? They're up there. They tell us the kind of vehicles. They tell us the kind of vehicles, ion thrusters, plasma ion thrusters, right? Quantum locking, any kind of metallic metal,
ion thruster, what?
Superfluid and movement, and electrical forces, and electrical forces. Bro, calm down.
Thrusters work in conditions that are completely different than quantum locking and super.
All you're doing is trying to disrupt the conversation, bro. You're a disinformation agent. I can see it.
The thing is, I mean,
so just insult me. Do you have the evidence, right? Do you have measurements? Any kind of
the universities
doing this, anything other than just your inexperience and thoughts about it?
Do you have anything but your professors?
Well, this is the thing. Okay, so this is the point.
Well, I am a professor, so yeah.
Well, that's the problem.
Let's suppose that Jayace is misinformed. Okay, right, and there is an echelon of intelligentsia and researchers who develop this stuff beyond the scope of most people's visibility and beyond far beyond the capabilities of the university echelon. Like, who are these people? Have you got any evidence of who these people are or where they come from?
No, that's a good question.
I don't know, dude. Just because people don't take your claims on face value doesn't make us disinformation agents.
No, bro, we were just building on what is happening with the Space Force, like what they're the most recent stuff, the most technological capable patents, right? That are up there, bro. They're just up there, okay? And
They're not,
if you
though.
say
You're just saying that. You don't
no, they're
actually
not.
have the thing to support it.
Bro, why would I lie about something like that? That would be stupid.
Can you give an
Because
example?
you have a belief you're trying to push on other people.
No,
Yeah, it's not technically a lie. Yeah, it's not like a lie. It's like something you believe, you know, and that's what he's trying to say. But to Paz's question, Pazza, do you think it would be like it would be like those people might be really, really rich, and maybe like one of them owns like a space company?
Well, I mean,
Just because you're like really convinced of something, that's not evidence of its truth or
No,
accuracy.
I'm going
Right?
off
You
the
could be
words. I'm
super
going off the words
convinced.
of the government. I'm going off words of websites,
but that's not
and
evidence either.
and patents and captains of the Navy admitting, yes, this is our technology that we use, right? It can go in water, it can go in the air, it can go into the space.
And
What they
I'd
call
ask them
space.
for the same
Open
thing.
the fluid.
I'd ask the
Okay,
Navy
go ask them, bro. I'm just
admiral,
telling you.
the Navy general, the government agent. I'd ask them the same thing. Can you show me the evidence? Let's see the mechanism. Let's see some measurements.
Bro,
Let's actually see
you're
the
type of person
scientific process.
what you want to do is you want to go see it for yourself and then come back and say, this is what I seen. It really exists. And people are going to say, oh, that's bullshit. I want to see it. And then they go see it and they come back and they tell everybody, hey, I seen the patents. I went to the government website. I talked to the colonels. I talked to the admirals. Oh man, you're full of shit. No, that's just the government. That's just government agents. You think they know anything about space? That's what you sound like. Only my professor.
I mean,
my professor said, My professor said, no.
The top people who work in that technology are saying that what you're saying is BS, right?
No, bro.
So I'm
No,
going to
bro.
go
I'm talking about
over
space.
you. But nonetheless, right?
So you're an astrophysicist? Are you an aerospace engineer?
Finish a freaking sentence.
Are you an aerospace engineer? Are you an aerospace engineer?
I go
Do
to
you have a degree in
university
that?
with a ton of them. Doesn't
No,
matter. I'm a
that's-
biochemist, molecular biologist, but nonetheless,
You're
that doesn't
using
matter.
academia. Right, you're using
I would love
academia
to
as
see
your
it.
god.
That would be great
As your
if I
god.
could see it with my own eyes. But certain things can look like other things, so
But-
you can
but-
never be 100% with that. What I'd really like to see, what would be better, is the scientific process behind it, the R&D with the measurements, the mechanisms, all the things required by science. That would be convincing.
That's not truth.
Okay, so if these things exist and you read them, what would you come back and say?
What do you mean? What would I come back and say?
What would be your evidence for reading some paper?
just-
What would you? You'd be like, oh, it's real now. It's real. It's real,
No,
guys.
I would provide
Yeah.
you. I would provide you guys with that, and then I would, with like the paper or whatever, the measurements, the mechanisms, right, where they're reported.
The
Right?
measurements.
Then I would bring that.
What do you mean the
to
measurements? The measurements
to-
what? From here to the
I
carbon
know
line?
you're making
Or-
claims and you
or
don't
the-
even know that you have to have measurements and evidence for them to be
Bro,
substantiated.
you're talking-
But yes,
you're talking about
the
distance
measurements
to space?
and
What distance
the
to space?
measurements and the mechanisms from
Of
the
what?
papers,
The
right?
measurements of
I
what?
could give those to you guys, and of your
The measurements of what?
claims, right? I'd have to sift through your specific claims, look for the measurements of those claims, right? And then I would bring that to the top people that work in that area at my university, have them duplicate it, see if they could duplicate it to actually verify that those measurements are correct. Then that would be convincing for me.
Can you tell me what those measurements are of?
Well, number one, as we were talking about before, temperature for quantum locking, superfluidity, superconductivity, any of that to occur, it can only occur under certain temperature scales. And I totally forgot. And they're typically cold temperatures.
Bro,
Yeah, I
negative
forgot that this guy
360
had mentioned.
and negative
forgot.
470.
Let him finish the sentence. Would you
I
please?
forgot that. I know.
I'm giving-
I
I'm
told
giving
you
him
what the temperature of the CMB was. I forgot that he had said before about ion thrusters, which are on the exact opposite end of the temperature spectrum for the conditions that those work under. So, like, none of this is adding up to me. Like, nothing you're saying actually comports with my experience of reality in these things.
Well, he started with a logical syllogism that sounded correct. I mean, he said gas pressure requires containment. We breathe gas pressure, therefore Earth is contained. That seems like a good evidence for that. And then he brought up
That makes a
helium
lot
is
of-
lighter than air and goes to the top. So he was assuming that it would get
contained, though.
trapped at the top of the container that he logically deduced before.
But we have a container just real quick. I keep on hearing this containment.
Sure.
And yes, we know air, yes, the atmosphere is contained. Containment does not require a physical container. It may
Yeah, I
sound
believe it
funny.
has to be
Hold on.
physical.
Let me know. It doesn't.
Okay, then show me it without a physical
If you let me finish the sentence out, it's very frustrating. If air has weight, by virtue of its weight, it will be contained. That doesn't mean there's a physical bottle around the Earth or around the atmosphere. It means that there is containment by the virtue of the air having weight. That is a velocity of those molecules greater going down toward the center of the Earth or the center of the ground if we don't accept the flat Earth.
Sorry, Zanik. Are you done?
Well, I just wanted to close with a closing statement. No, I'm fine.
Yeah, Right. So even if we gave it to them with no actual measurements of the space being superfluid or superconducting, even if that was the case and we could verify it, that still doesn't mean that there's objects up there quantum locked, because that requires specific materials. Not every material can quantum lock or superconduct or superfluid, right? It's a very certain materials that can do that, and they're under very specific conditions. And if some of the superconductors, if the conditions are just slightly off, it's not going to work, right? So this is why I find it hard to believe that there's just this stuff quantum lock up there. That's a difficult thing to do.
I hear you, Jace. Do they have to make satellites out of specific materials, or can they use just any old material laying around?
Yeah, they don't make it out of like barium or beryllium
Also would.
superconductors, that's for sure.
I'm just wondering if it's specific. Can you just clarify? Is it a specific material they have to make the satellites out of, or not?
Yes, they would have to make
Okay,
the
that's
satellites out of a superconducting material that actually quantum
No,
lock
right
under
now.
the
No,
conditions.
the satellites that we send up right now. Do they
Oh, yeah.
have to be made out of a specific material or not?
No, I don't know. It depends on what the satellite's for, right? Some of them they make out of like lightweight stuff. Some of them can have steel. It's just depending on what that satellite is for. So if you had a specific satellite in mind, we could look up what it's made out of.
How about like the ISS? Is that? Are you saying they
That's a
can
good
use
question.
like any metals, or like do they have to be specific ones that can endure specific temperatures and stuff like that?
Yeah, I would think that obviously they have to make it out of something that's going to be able to endure the temperature that it's in. That should be just a given.
Yeah, so there are specific materials they're sending into that area for a specific reason that they give us. And it sounded like
Yeah.
he was kind of putting forward maybe that specific reason isn't the specific reason, and maybe there's another reason. That's all I
Well,
was hearing.
we're missing the minutia of how difficult quantum locking actually is and how sensitive it is to changes in temperature, changes in pressure, changes in bond structure of the actual material. If it gets to a certain temperature or gets hit by a certain kind of electron or whatever, the bond structure can change. The actual chemical reaction can occur, changing the bonds of how it's put together, and then it can no longer be a superconductor. There's a lot of minutia that I don't think you even know about, and that's why it seems possible to you. But when you dig into the minutia and you actually try to do it, you see how difficult it actually is, and it just doesn't seem feasible.
Okay, I hear you. I was reading a little bit about it, and I just was going to read this for the room if that's okay. And I think it'll help a little maybe with what quantum locking is, because it says quantum locking relies on the Meissner effect, which causes
Yep.
superconductors to expel magnetic fields, combined with flux pinning that traps these magnetic field lines with defects of the superconductor. When cooled below
Yeah.
their critical temperature, superconductors exhibit this expulsion and pinning effect, allowing them to lock in space relative to a magnetic source. This
Yeah, so
interplay enables stable levitation. Yeah.
Yeah, so in simple terms, what that means is with certain superconductors, something called the Meissner effect can happen, where the magnetic field lines get reorganized in a different way than how they are at like room temperature. And then another material can actually be what's called flux pinned, to where the field lines are they're in this configuration that holds the other thing in place. But that is incredibly sensitive to the environmental conditions. If certain things change, that flux pinning stops and the Meissner effect fades away.
But with a pretty consistent temperature and pressure as we go out further, it's pretty consistent. So, like, could the sun and the moon and these different objects be putting off these magnetic fields and then causing this like momentum of this fluid or something? I don't know if that's what that gentleman was trying to say. I don't know if they could be considered superconductors or not.
Well, most of the superconductors, the low temperature superconductors that have been verified to actually do this quantum locking thing, are composites. They're made from a bunch of different chemicals mixed in a sensitive ratio. They're not just made of like random everyday things, right? So the planet, the space, or whatever object that is doing this flux pinning to our I would guess would be a satellite that it would flux pin, right? The planet would flux pin the satellite to it, right? So you would need the planet or whatever the space material to be made out of like this highly specific ratio of elements, which makes it even less plausible.
I hear you. I hear you. Thank you for sharing that and explaining that for me. Appreciate it.
Yeah. I mean, I
Right,
totally
it's
hear you.
high-tech
It's
stuff.
fun to think about. It's fun to think about and stuff. I don't mean to be a buzzkill, but like, geez, let's stay
I
somewhat
appreciate.
attached
I
to
appreciate
reality.
it, Jace. Yeah, no, I totally appreciate it because yeah, my version of the sky is super far from reality. So yeah, I totally understand it. But I believe in like they're the heavens and everything. So it's like godly realm stuff. So
When these things first started coming out on the forefront of technologies, superconductors, that was a big deal. I mean, they were dealing with all the interconnects of semiconductors now having zero resistance. I mean, you can see that now no heat's being produced, current flows through it, nothing's resisting it. I mean, there's huge ramifications for that. That was 30 years ago, 20 years ago. Now things are going even farther. They're looking at these other fantastic qualities that Jace is kind of alluding to and high level describing. It's pretty cool stuff. But I don't think our heavens above are involved in in any of these processes. And that's why I want to bring up the fact of containment being just the mere fact that we have measured and can easily show an example scientifically that these gases all have weight. If they have weight, it follows suit with the fact that all the laws of hydrostatics are valid. and make total sense why we have an atmosphere and why it's contained. I mean, doesn't that make sense to you? If we can definitely measure weight, that would all those chips would fall align with the fact that the containment is due to the gas having weight.
Yeah, no, that does make sense to me. The part that doesn't make sense is pulled to the center or whatever, just because when I think of the Big Bang and everything going way far apart from each other, I don't even understand how everything could pull back together. So maybe I'm just not on board with that part of it.
Well, that's why I kind of preface that statement with, or kind of parenthetically talked about it being, it doesn't matter whether it's flat or round. This thing we have that is down.
Very good point. No, yeah.
If it's down, then that causes hydrostatic. But of course, we say it can't be flat forever and down. It can't be parallel everywhere. We think it's all the down lines, all the plumb lines are not parallel, and it's all pointing to the center of some mass based on a mass discussion. But the atmosphere discussion is a little easier just by understanding the fact that these atoms, these molecules all have weight, and it can be measured.
Well, Zanuck, right? I think not only is his understanding of gravity different than you or mine, also his understanding of the Big Bang is different than you or mine. Like, we don't think it was this like explosion of material that was going out for gravity to somehow contradict by pulling it in, right? I understand the Big Bang as just being the evolution of the epochs of the universe that has little to do with actual matter. Like, there's phases of it that have to do with it, but it's a minor detail.
Agreed.
Like there's other universes or universes before this one or something?
No,
just
symmetry breaking is the key idea. The key thing about the Big Bang is the process of symmetry breaking.
It has to be said that it's all completely non-intuitive.
Non-intuitive, yes.
Yeah. Well, it becomes intuitive if you understand physics, and it becomes pretty simple at that point, right? Once you know there's theorem and how the laws of nature emerge from that, the idea behind that really make the Big Bang is take after that.
But it's uniform, right? When you say symmetry, do you mean like this, like how like a cell splits or something, or like what do you mean by that symmetry?
No. So there's something called gauge symmetry, which is related. All right, I'll try to keep this quick because I don't know if everyone wants to talk about the Big Bang. There's something called gauge symmetry, which is related to conditions, be it radiative, temperature, pressure, things like that, of how at different points, how the different forces, the different interactions, gravity, electromagnetism, electroweak, strong and weak forces or interactions, how those emerge from being one force to splitting into the separate forces that they are today, or the separate interactions that they are today. Now, matter has a role to play in that, but that's the big thing, and a lot of it is done with no relation to matter. It's just how the symmetry, how they break, and how the forces split from being a combined force to being individual. At least for the early parts of the Big Bang. Then there's something that astronomers and astrophysicists refer to as the hot Big Bang that is related to matter. That's when the temperature of the universe cooled enough for actual matter to form, and energy density got captured in that form of matter and all the different things that matter can do. So that's just one aspect of it. Typically, astronomers will refer to that as the hot Big Bang and refer to the overall thing as just the Big Bang, or the FLWR metric, or the lambda CDM model. They all kind of represent this overall symmetry idea.
Okay, I kind of understand where you're going, but are you saying there's temperature without matter?
Yes. There can be radiative temperature, and there's just energy density in the quantum fields themselves, right? Any energy. So when I say temperature in this context, any energy above or below zero, so it's not exactly 0.0 infinity zero, right? So anything above or below that is temperature or energy in the context of the Big Bang. So it doesn't just rely on matter, like air molecules, to have temperature. The quantum fields don't ever have just exactly zero energy. They always have some amount of energy, and it fluctuates constantly. So that is like a residual temperature. And then there's also radiation that can provide a temperature too. Photons and certain particles of the electromagnetic interactions can bring temperature in this context. It's really just energy.
What do you call that? Like on that quantum field, like those, I guess, like almost spaces void of matter. What do you call that?
The space is void. Well, there's like the what's it called? The interstellar regions, right? I guess they just intergalactic, interstellar. Intergalactic would be, obviously a bigger region, but they call it like the cosmic web or whatever. You ever see that picture with like those kind of shiny?
Yeah. I'm talking on the quantum level though. You're saying there are areas without devoid of matter with temperature.
I got you. No, not on. It's not like in an atom. There's, between the proton and the electron, there's some area with temperature. That's not what I'm saying. There's no matter around in these beginning parts of the Big Bang model. The temperature, the energy, just comes from the residual energy in certain quantum fields. It's not coming from space in between. What quantum mechanics and quantum field theory would say about the space in between the electron and the proton per se is that there's this energy density from the field is always there. And I'll leave it there. There's some things we could talk about observations that actually verify that, but it just proposes that there's an energy density everywhere. Basically, there's some amount.
Okay, so then the field would be something that's eternal, that has just been forever here.
Yeah, kind of, right? Because the symmetry breaking, when the universe gets to these certain energy densities, to keep it simple, the fields kind of change. They're dependent on that energy density. Like it's proposed that there was like in the start of it, there's just this one quantum field, this granddaddy quantum field, and then as it fluctuates, because quantum fields fluctuate in energy constantly, as it fluctuates, a fluctuation happens that's large enough to actually symmetry break the field into two fields now, and so that would be two interactions, two forces now exist, and then that just repeats into three and into the four that we know today.
Okay, cool. Do you think, without begging the question, you can show a field without a field maker?
What do you mean? Because we're not proposing that the field is something that you can grab and like show to people, but we can show that a quantum field with these properties would have these effects on this experiment, and actually do the experiment and see if the experiment discredits that quantum field that we had proposed due to the results. If the results don't match what the prediction of from that field would be, then we can discredit that field as existing.
Okay, yeah, I see what you're saying. I guess what I was trying to say is, like, if there was something always, is it possible there was a maker of that something then at that point? Like, or does this field
Yeah.
exist eternally? You know what I mean? Like, so it's interesting.
good.
Could the field come about on its own?
Sounds
It's a good
suspiciously like
question.
sounds suspiciously like ether.
Well,
this-
physicists are debating that, and astronomers, astrophysicists currently, they are debating whether these quantum fields or the granddaddy quantum field is eternal, it's always there, or if it emerges from something else that we just don't know yet.
Are the reactions that occur physical in these fields, right? They're like physical reactions. So, correct?
They're not like chemical reactions, but they're definitely physical. They're part of physics.
Well, yeah, I want to try to help with this debate on if it's lived, if this field has been around eternally, because I have an interesting concept to present to you. If you have an infinite amount of physical reactions in the past, it wouldn't be possible to participate in the present moment.
Yeah, it's could be somebody's hot micing. Somebody got the hot mic. But yeah, that I mean, sure.
I give the example of like, if I gave you a candy bar after an infinite amount of time, when do you get the candy bar? See, it's like you can't get there, you know?
Yeah. Well, I would say that's not necessarily like a physical situation, right? Like, I mean, it is a situation, but it's not like a what physics would study. Physics isn't going to study when you give me the thing you're going to give me, right? We're talking about like the natural world. Interactions between humans has a role to play in that, but we're talking more about the physics aspect of the natural world.
Yeah, exactly. And that's kind of what I'm trying to say is, like, if there's an infinite amount of physical reactions before this moment, we can't get to this moment. So the idea is basically that the present moment proves the fact that there's a beginning.
Yeah, I get what you're
Philosophical.
saying.
It is philosophical.
I don't think like I don't think it's right to quantify physics interactions as like in a number, like being infinite or not infinite. I don't think that that's the part that's leading to the resentfulness of me to accept that,
Oh, fair enough.
right? Because typically,
So are you talking about
infinities.
You're talking about Zeno's paradox.
Yeah, that's I was going to say that before, similar to Zeno's paradox. The problem is though, nature takes the infinitesimal limit, right? It does the calculus and gets a result. It doesn't just stay in infinite limbo.
Yeah, you would agree that the laws of nature follow all the laws of logic, right?
Yeah.
Yeah, so what I'm trying to put forth here is a logical argument for nature, seeing that nature must follow the logic.
Yeah, I got you, man. I got you.
Maybe we could like write a paper about it and get peer reviewed. It'd be awesome. I'm just kidding. Do you think if you presented that kind of argument in the scientific community with like enough logical syllogisms as well as mathematics to back it up, like with the infinite regression and everything. Do you think that would be something considered in the scientific community?
Yeah, yeah. I mean, if you put it the right way, I think most things, if it's formulated right with the proper supporting kind of minutia with it, usually, right? The journals, it's not about what you're publishing. Journals have requirements for like standards and format, right? So you just have to meet those, right? So if we could formulate it in that kind of way, and then obviously the peer reviewers, they then like if you meet the requirements and stuff, but you're just totally wrong, your measurements are just horrible, then yeah, then the reviewers can say, hey, like you gotta fix this. This is all out of whack. But if we formulated it correctly and met all the standards, anything can be published.
Nice, awesome. Start working on it.
Yeah. I wish, man. I'm so backed up with this freaking genetic dinosaur thing.
Man, you've been doing that for a while. That's so crazy. I bet you that's interesting.
Yeah, it's like a 5-year project. We just started a couple months ago.
It'll be cool to hear the findings if you ever share, if you're allowed to.
Yeah, definitely. I actually do have to take off though, so it was good chatting with you guys. Have a good night.
Yeah, man, you too. Have a good night, brother.